after that, we'll start. Let's just give 2 minutes and we start at 2:05. Maybe some other colleagues are still finding out how they can log in, the internet issues and so on. Okay. France, I've seen your comment, and I'm not going to be fast. So for those who want to get today's materials, kindly check in the same Google Drive, the same Google link that we've been sharing. I updated it with the materials for day 5. So you can check. There are 2 files. There is a PowerPoint, the one, and it's in PDF, and then we've got 2 R scripts. And one is named cluster analysis. The other one is cluster self-read. I saved it as self-read because I want you to practice at the end of this session. Then you'll do personal practice at your end. Okay, but we'll go through the cluster analysis, our scripts together before this session ends. Okay. I think we can start now. And then other people can join us as we move. All right. I'm going to share my PowerPoints. Okay. So with day 5, we're going to look at cluster analysis, introduction to cluster analysis. I strongly believe that at the end of this particular session, at least you're going to be well versed with what cluster analysis is all about. I'm going to try to be as slow as possible such that everyone is able to move on my pace, and I'm also able to move on your pace at your end. Okay. From Thomas and Susan, they looked already at some of the statistical techniques that we've been talking about throughout this week: factor analysis, and then principal component analysis. And then today we want to look at cluster analysis. As we give you an introduction, we assume that at the end of the training or at the end of every session, you really find time and see how you can relate these particular techniques to your personal data. Because remember, we said one of the advantages with when using our programming language, you can reproduce the codes. The codes that I've worked on a project X can be reproduced for a project Y, provided you know what each particular command does. And that is what we anticipate. Okay, so let's dive in. We're going to look at introduction to cluster analysis and see what it is. We're going to just look at a little bit of theory after understanding it very well. And then we are going to run our cluster analysis script and see how practically it's being done. All right. So when it comes to cluster analysis, I'm going to, sometimes it's called the subjective segmentation. So in case you find a different name, it still means cluster analysis. But like in the first, on day 1, whereby we're talking about an overview of multivariate analysis, and we looked at different techniques and asking ourselves what they do. when it comes to cluster analysis, the main task is that I want to find out which objects are similar. The object could be in terms of observation, could be in terms of item, depending on the data that you've collected or on your interest, on the different things that you want to cluster together. But one thing that we want to see, are these objects similar? Do we see any pattern, okay, when we are looking at different objects? So we need to, as we proceed ahead, at the back of your mind, put it that we want to see if we can see objects that are similar or patterns that are similar, because we are saying that cluster analysis is a subject segmentation. And also, apart from seeing that the objects are similar, we also want to, as we move on, we want to see that the moment they are grouped, they are homogeneous. Within the group, they have to be homogeneous, implying that they have got similar characteristics. And they differ from other groups. Okay, so the takeaway message here is that when we talk about cluster analysis, it's all about finding observations that are similar. And then also, so that the groups that are put together, they should be homogeneous within the group. Okay, and when you talk about homogeneity, it implies that each object within the group, they are similar to each other. As we are going to see in the coming examples, we are going to see that very well. And apart from seeing that within a particular group that everything that inside there is similar to the other, but also they have to differ from the other groups. So each group should be quite distinct. In other words, if we've got each group, it could be like each cluster should be distinct from the other, in the sense that when you look at the observation of one group, then it should be dissimilar to any other object of the other groups. As we're going to move on, we're going to see some of the concepts or the terms that are being used when it comes to cluster analysis, like similar, then dissimilar. With the dissimilar implying that if they're different groups or clusters, they have to be different, but within the group, they have to be similar. Okay. And also, we said that when it comes to cluster analysis, it belongs to an interdependency technique. Okay, this is something that I picked from the day one, and I thought that we can remind ourselves. And also, I still echoed that when it comes to cluster analysis, we use to group similar items within the data set into clusters. You can call them clusters, you can call them groups. And in this particular case, when grouping the data into clusters, we aim at putting similar items or observations in one cluster, but they have to be different from the other clusters. Still also, today we are going to understand different terms about the intercluster correlation and then the intercorrelation distance. When we talk about the intracluster distance, this one, we look at the distance within the data points within one cluster, okay? Assuming that we have got a cluster which has got similar observations or items. So the distance in between these data points is what we call the intracluster distance. And we're going to see how do we calculate this particular distance, because we are saying that it should be small. The shorter the distance, it implies that the particular points or the items are close to each other, or they have got a similar pattern. And then when we talk about the intracluster distance, this one looks at distance between data points in the different clusters. And in this particular case, we're saying that ideally they should be large, because we want to see that within the cluster, the distance is small, but between the clusters, the distance is what? The distance is large. And then as we're going to see on, we shall see the different distribution as well as finding the patterns. Okay, before I move on, let me check in the chat. Are we on the same page? Is the speed okay, or I'm too slow? I increase. Are we on the same page? Okay. All right. Okay. Now let's take an example. I want us to consider this particular example where we've got the toys P, Q, R, X, Y, Z, A, B, C. It is just an example that I just want us to use for us to understand what cluster analysis is all about. And then when we go to R, we shall use a complete data set. So in this particular data set, for example, looking at the toys, now in this particular case, these are the observations I'm considering. I've got a variable called shape. And under shape, I've got, like, for example, toy P, it's a triangle, Q is a circle, rectangle, etc. All right? And then when I come to color, I've got two colors. Either a toy is red or blue. And then the make of the toy, it's either a metal or a plastic. Okay, so now this is like a data set that I've picked, and I want to use it such that I elaborate more of what exactly we are looking at when it comes to cluster analysis. Okay, now we're going to, based on this small data set, to get to know how do we build clusters, or how do we group the different variables. Okay, let's go back to this particular, to our table. Let's assume that we consider shape. We've seen that under shape, it's either triangle, a circle, or a rectangle. And with a triangle, we have P, toy P, we have toy A, we have toy B. So we are going to, if we are to consider grouping with a triangle, because sometimes it's natural grouping, then it implies that under triangle, we shall have P, A, and B. When we come to circle, we shall have Q, X, Y, and then C. In case of rectangle, as our shape, we shall have R and Z. All right? So this is what we are having on this particular slide. Because remember, we are saying that when you're going to group, you group according to a given variable of interest. It's up to you to choose whatever variable that you want. So in case we consider shape, like I mentioned earlier, we are coming up with 3 clusters, or we are coming up with 3 groups. So because we based it on the shape, we have the ones in the triangle, and we got these particular observations. Then within our circle, we've got Q, X, Y, and C. And then the rectangle, we have R and what? R and Z. So what we are seeing here is that within the group, you have homogeneity. Okay, because within the group, we are saying that P, A, and B, they are triangles. Then R, Z, they are all rectangles. And then with Q, X, Y, and C, they are all circles. So within the group, they are the same. They've got similar characteristics, but between the group, there is homogeneity, or they are distinct, they are different. Because in between, we have the triangle, the circle, and then the rectangle. Okay, how about in case we consider color? Remember, when it comes to color, we say that they belong to 2 categories. Either a toy is red or it is blue. So when we come here, we find that we're going to only have 2 groupings or 2 clusters, where we have red and then where we have blue. Okay, what about in case we consider both? In case we consider shape and then color, implying that as you add the different attributes, of course, the number of clusters are going to increase, because we are seeing that initially when we considered only the shape, we had only 1 circle. But as we added the color, we have circles that are red, and then we have circles that are what? That are blue. The same applies to a rectangle. We had, when we considered only the shape as a rectangle without the color, now that we brought in the colors, the grouping is increasing. So as you increase the variables, in this particular case, it implies that also the number of clusters or the grouping is going to increase. So let's assume that, okay, what if we add, for example, the metal, where we say within the metal, it's either plastic or the metal part of it. Then it implies that also in that particular case, the number of clusters or the groupings are going to increase. Okay, so in summary, what does that mean? When we are looking at cluster analysis in this particular case, Remember, we mentioned it is an unsupervised technique. There is no the variables are not depending on each other. Okay, and it's not like in the case, for example, where in case you're looking at logistic regression, whereby you're looking at a binary outcome. And in this particular case, you want to understand how likely the independent variables will influence your outcome variable. Within here, there is nothing like dependency. And so you have a choice to take any variable you want. You have a choice to select whichever attribute that you want, like the way I've explained in the previous slide. You can either, depending on your variables or the attributes, you choose any variable that you want or attribute, because in this particular case, there is nothing like this variable is depends on the other. Okay. Also, different attributes will lead to different grouping. I've explained that. All say different variables will lead to different groups. We saw for the case of the shape, we saw for the case of color, we saw what about when we combined? And I know in case we consider also the last attribute, still the groupings are gonna change. The group is homogeneous based on the selected attribute only. Okay, so it is homogeneous basing on the particular variable that you've chosen. Like the one of shape, like I mentioned, we had the triangle, the circle, and then the rectangle. And so when you take different attributes, you'll get different groupings. Like an example where we had, where I showed where you have the shape and then the what, and then the color. Of course, automatically the groupings will change. So the point is, the more attributes you take or the more variables you take, the more clusters will be required. So, but it's up to you to consider which attribute you want to use or which variable you want to take. Do you want to consider color only? Do you want to consider shape only? Do you want to consider both, or considering all the variables? All right. So remember, as you increase the number of attributes, automatically the number of clusters will increase. But it's up to you to choose, since there is no dependency of these attributes. Okay, and also the segmentation develops on its own based on the values of inputs. Like I mentioned that the grouping comes naturally depending on how the variables looks like, because we saw, like, for example, color, it is natural that this particular observation are either blue or what or red. And I've already mentioned that is unsupervised learning. And also, in this particular case, what we do, we adjust the groupings are based on the independent variables. We don't have issues to do with dependency. Okay, let me pause a little bit, and I see in the chat if, can you take the last slide again? One file is open. It's not. Are you seeing my slides? Somebody's complaining. Okay. Okay. Great. Now, are we on the same page? Type 1, and then I continue. Okay. All right, let's continue. So, at least from what I've just talked about, right now we know what cluster analysis is all about. That was just a basic introduction, such that we understand how the grouping looks like, and then we also need to the concept of seeing the intra-cluster, because we want to understand the distance within a given cluster should be small, or within the cluster, and then it will be large when between different clusters. So sometimes we want to ask a question like, okay, now that I've got these particular clusters, the question is then, how do I determine, how do I know, like, for example, how do you know the objects are similar to each other? of course, there are many ways on how you can answer that particular question, but one of the possible ways we can do that is by looking at the distance between 2 points. And there is a very common method, the Euclid distance method. And in this particular case, what happened is that for us to get the distance between 2 points, assuming that I've got D, I is my first object, and then J is my second object. I've got many parameters. Let me assume that I've got parameters P. So I get the first observation, in this particular case, my first object, then I minus it with the second object. And then everything is within absolute and I square till when I get to the last parameter, and then I take the square root. Let's assume that, well, maybe you've got only 2 observations and you want to know the shortest distance. For example, you're moving from this particular point to the other. Of course, we see that to come up with the length here for a straight line, we're going to get the u1 minus u2 square, and then everything will take a square root. But in this particular case, what you can see that, yes, it looks like a straight line, but there are different possibilities on how, for example, this particular bird will move from this particular point to the other. Using the program, or when you're using R, we are going to be, R will show us how we can compute the distance between clusters in just a command, but we're going to see that as we move on. So mathematically, this is how we calculate the distance between points. Okay. And there are also other ways on how we can do that. We say that from the previous slide, like the bird can use various ways to move from one point to another. There are many possibilities, but in R, or in our case, what we're going to do, we can also use what we call the linkage function. Within the linkage function, it just helps us to look at the intermediate cluster distance. The first one, I just showed how you can do it mathematically, and then we can also use what we call the linkage function. We are going to still see as we move on during the program. Considering the linkage function, still here, what we are trying to do, we are trying to see, we are saying that there are various distances within the groups that can be devolved. You have many distances devolved from one group to from one group to the other, but you want to consider there are different possibilities that you want to consider. For example, the shortest distance of them all. If in that particular case, then we'll call that one a single linkage. There are also another circumstances whereby you want to consider the farthest points in between the clusters, and then we're going to call that the complete distance. Please mark the words, because when we get to the R script, I'm going to be using the same wordings. Okay, maybe to illustrate that more about the linkage function on the next slide, assuming that I've got 2 clusters, I've got this small cluster here, and then I've got another cluster here. With the linkage function, what I've just explained is that when it comes to of course, for example, if you consider this particular point, you might find that you can have this particular point and then it moves to different points and you get various routes, like I mentioned, many routes that you can consider. But in case you consider the closest between these 2 clusters, when you consider the closest distance, then we call that the simple linkage. However, in case you consider the farthest points between the 2 clusters, we call that the complete linkage. For example, in the green, assuming that I've got my far point here, and then the other farthest point within this big cluster, it is this particular point. So we'll refer to that as a complete linkage. We're also going to see that in R. How do we compute the distance between clusters using the complete linkage? And then also, there are also other functions like the average linkage, etc. For the simple, it implies that I'm taking the shortest. For the farthest, I'm taking the complete linkage. We've seen how we can compute distance mathematically using the Euclid distance, and then now using also linkage function, just in a pictorial way on how that is supposed to be done. Just remember that, like I said, you can have different distances. For example, you can have one point being connected to different points, so whereby it has many parts. But we are saying that in this particular case, with the shortest one, we shall use the single, and then the farthest we shall have the complete linkage. Okay. I think I've explained about the complete. We are taking the most far endpoints. There are also other approaches, for example, the average, and then etc. But it's all about like, how can you calculate the distance between objects, okay, and then between clusters, between objects and then between the clusters. Okay. So for us to do that, there are different approaches you can still use when, in case you're interested in calculating the distance between objects and then between clusters. But we're not going to look at all of them. I'm going to just look at a few. And one of the common one is the hierarchical clustering. And this particular approach, it's usually applied in case you're having a small data set, and it supports you to show you each stage of the observation linkage. The point is, whatever we are drawing at, we are trying to see how many clusters, the number of clusters that we are going to consider, how do we get the distance between the clusters and within the cluster and then between the clusters. There are different ways on how you can visualize that using a dendrogram, at the same time also the script plot, which I think with the script plot has been talked about throughout this particular session since Monday. And with the script plot, the point is that we look at the number of clusters and the within cluster variancy, okay? And then we'll be able to, with it, we can be able to determine the optimal number of clusters that we need. If we continue further, I've already mentioned about the script plot. What it does most of the time, like how my other colleagues have been elaborating in the past days, what it does is that it gives us all the possible clusters and the within group sum of squares. So on my x-axis, I have the number of clusters. For example, I've got 8 clusters, 7. I come to 4, and then up to 1. And then on the y-axis, I'm having what is called the within group sum of squares. So in this particular case, remember the point is that we want to reduce the within cluster variability. You find that, for example, from cluster 8 up to cluster 4, the within group variability is very small compared to when you're having from cluster 1. When you're sloping down, there is a big variability within the group sum of squares. And then the same applies from 2 to 3. But as you move from 3 to 8, you find that the variability keeps on reducing. And so if you look at this when you look at cluster number 3, you find that we are seeing like what we call an elbow. And this elbow is the one that is supporting us to give us the optimal number of clusters that we need. And then depending on the data set, where we see the elbow, like how it was illustrated yesterday by Professor Susan, it implies that within my given data set, these are the number of clusters that I need, the optimal number of clusters. Let me pause a little bit and then I check in the chat if we are on the same page. Are we on the same page? Type 2. Okay. All right. Okay, great. In case you have a question that is technical that needs more attention, you can type it in the Q&A and you'll get help. All right. Okay. This one I've just explained about the script plot. I'm still building on from what was shared. Whenever we have like if the number of cluster is 1, in that particular case, we are having the total variance within the data set. I've just mentioned that where we see at the elbow, like how it was illustrated yesterday, that is giving us the number of clusters, the optimal number of clusters that we need to be able to group our variables of interest. There is also, apart from the script plot, there is also another one, how you can visualize your data within cluster analysis, which is called the dendrogram plot. Okay, and looking at this one, the dendrogram is a tree-like diagram that is used when you want to illustrate the arrangement of the clusters produced by the hierarchical clustering. It's just a visual presentation. However, it shows the arrangement of clusters formed at each step of the hierarchical clustering process. I'm going to share an example. Maybe within its structure, the different things that you have to note in mind is that each data point, since it's hierarchical in nature, each data point gives us a cluster. We start with a cluster, and then we keep on building and see how they get nested in the other. So the leaves, or what we call the terminal nodes, they represent individual data points. For example, if we go back to the table that I showed you earlier, we can have the different individual data points representing each toy. Okay. And then we are going to see that we're also going to see how the branches are being formed, in the sense that you can merge 2 clusters. And in this particular case, it implies that the length of the branches, for example, in this particular case, if it is small, then we are going to group it into one cluster, etc., and then etc. Okay, so the closer the branches, then it implies that they are more similar to each other, then we can put them under one cluster, etc. Let's take this. This is how, in case we run it in R, how it's going to look like, depending on, so in case whatever these particular points that you're seeing at the end, these are the ones that I'm calling the nodes, they cater for a given different data points. For example, like the one I mentioned within the toy, we can have these different nodes as each toy acting as a what? Acting as a cluster. But in case, for example, maybe you have like these ones are next to each other, we can have like cluster 1, this can be cluster 1, cluster 2, we can have cluster 3, this can be cluster 4, we can have 5, this can be 6, this is 7, then I can have 8, I have 9, this can be 10, then this is 11, and then this is 12. Okay, since it's hierarchical in nature, you find that you look at usually here we've got the height and see how it changes. So in this particular case, you find that cluster 6 and 7, they're almost close to each other. And so we can collapse this into one cluster. So instead of having 6 and 7, we can collapse it, and then it becomes only one cluster. And then it implies that, so in that particular case, it will reduce, for example, and then we shall have now 11 clusters. Now moving up, you find that also this cluster here has been joined again by another cluster based on this particular point. Now, if I call this, for example, if I call it A, and then it also joined with B, I can still collapse the whole of this to become one cluster. And then I can also collapse this to be one cluster because they are close to each other. And at the end of the day, as I build going upwards, this cluster here, is also joined with this cluster by this particular node. And then the whole of this, I can still dissolve the whole of this into one cluster. You find that as we build upwards, and then as I continue, I see that also I can have at this particular point, I've got this cluster, and then I can also have the red into, I can have the red into one cluster, which later joins here, and I've got like the two of them, I can have them into, again, one cluster. So at the end of the day, what that implies is that you can build different, these clusters are nested in the other. So as we check the different distances within these clusters, we can try to bring them close and see the ones that are close to each other, we put them under one cluster, and then the ones that are far from the other, we group them also differently. And then also, you can be able, for example, with this particular visualization, assuming that I put a line here and then I cut off the upper part, then it implies that now I'm going to remain with only two clusters. I'll have this one here, okay, which has got, and then I also have this other one on the left and then on the right. All right. So in case, for example, I cut off from here, what is going to happen if I cut from that particular point? I'm going to remain with this cluster. The number of clusters are going to increase. I'll have 1, I'll have 2, I'll have 3, then I'll have 4. So that is how the dendrogram plot looks like, or can be illustrated. And it's just also supports us to find out how the clusters can be grouped. And then, of course, there are other ways or methods that you can use to enable you to get the optimal clusters. All right. Okay. So in summary, the dendrogram provides a visual summary of clustering process, how we move from the many clusters, and then at the end of the day, we diffuse them everything to belong to one cluster. For example, the one that, in case we are to consider our toys, and then at the end of the day, we consider that all the other variables of interest, they belong under the what? Under the toy cluster. And it's also just helping us to see how clusters are formed and at what level of similarity or dissimilarity. Okay. Also, the other way on how, apart from the hierarchical clustering, we also have what we call the non-hierarchical one. And in this particular case, we use the k-means clustering. All right, this one is very direct and very simple, because at the end of the day, it is you to decide out, looking at my data set, how many clusters do I need? It's up to you to decide out. All right. So, and most of the time when we look at the none, especially when you're having huge number of observations, this one, you can easily build up the algorithm and decide on the number of the clusters that you need. For example, you can say, I need 8 clusters, I need 5 or 10 clusters. So in this particular case, my K, the K that you're seeing here, stands for the number of clusters that you need. But like I mentioned, you decide how many clusters are you gonna have. Remember, as you increase the grouping, then automatically the number of clusters that will increase. But also there are ways on how you can, like for example, we said for the case of the script plot, whereby it tells us, okay, the optimal number of clusters that I'm gonna have are gonna be 3, or I need 5. But when it comes to the non-hierarchical, we use what we call the k-means clustering. And here it's up to you to decide the number of clusters that you need. So this particular algorithm is implemented in 4 steps that we are going to look at. All right. So step number 1, you partition your objects into k non-empty subsets, but you do this randomly. So, for example, looking at the toy example that we looked at earlier, what you do, like, okay, how many clusters do I need? Let me say, assume that I need 3 clusters. So I'll randomly I'll randomly partition my data into three subsets. Remember, they have to be non-empty, implying that these different subsets, they'll have the attributes of interest that we are looking at. Okay, that is step number one. Don't forget that we are going to partition the objects into K non-empty subsets. All right, what about step number two? So after the partitioning, that I need this number of clusters, we move toward step number two. We need to compute the seed points as the centroids of the cluster. Okay, and so in this particular case, so step number one, you've done the partitioning, and now you want to create the what? The seed points as the centroids of the clusters of the different partitioning. Assuming that, let's take an example that maybe you partitioned, each cluster has got, for example, 15 observations. Okay, we have 15 observations, we've partitioned, and then let's assume that you're considering maybe an XY and an XY dimension. So for us to get the seed points, which I'm referring to as the centroids, it is the same as getting center. It is like the mean point, or the mean point of the cluster. So in this particular case, let's assume that within my subsetting, in one of the subsets that I've got, for example, in this particular case, I've got 15 observations. So if it is if there are two observations, that is the X and Y, maybe I picked two. If I choose two attributes of interest, then I'll consider getting the y-axis, getting the different variables within. For example, let's talk about, I was going to give for the example of the toys, but within the toys, we don't have quality. The variables are not quantitative, because when considering with the clustering, they have to be quantitative in nature, such that we add our observations, and then we divide by the total number of observations. So in this particular case, it will apply for the case of the X, and then it will apply for the case of the Y. Maybe let me just give a, let's assume that maybe you're considering, for example, you have your Y, and then you have your what? You have your X. So we are saying that within your X variable, which has to be quantitative in nature, you add the different points that are within that particular cluster, you divide by the total number of observation. You do the same for the case of the other parameter, which is Y. Okay, in case I'm considering Y, you also add the total number of observations, divide by, you add and then you divide by the total number of observation. And so in that particular case, you'll be able to come up with what we call the mean point, or the centroid, which is the center. So assuming that in my case, maybe if that is my, maybe within this particular cluster, I've got that centroid, I get another cluster, which also remember these clusters that I chose, they are from my step number one, I said I'm partitioning objects into K non-empty subsets. So K, depending on what you've chosen, if I chose 3, so in each cluster, I'll come up with a mean point, okay? And then that way, if there are 3 of them, then I expect to come up with 3 centroids. If there are 8 of them, if there are 8 clusters, then I'm supposed to come up with 8. I would have 8 centroids, or the different mean points within the what? Within the non-empty clusters. And so with that, the next step is that now assign each object of the cluster with the nearest seed point. What do they mean? For you to assign each object to the cluster within the nearest, for example, if this is my centroid point, now of course the ones that are within, we shall say that these ones are within the cluster because they are close. but the ones that are far in a different cluster, then those ones are what? They're not going to be close. So that's why they are clustered in a different cluster. So what happened is that we repeat this same procedure. Of course, with R, we just need to run the command. What happens in this particular case? You go back to step number 2 until when we do not see any change. In other words, you've reached the optimal subsets. I'll put more details on that when we come to R, and then we see what happens in case we are running the different commands. Okay. So just a few things that this one I've already illustrated. I'm going to just talk briefly about the more details, and then we can go to R and see how we can do the things practically. Okay, this is just a summary of the details I'm talking about. We talked about cluster analysis as clustering. And what we are looking at, we want to group sets of objects that are similar to each other. And within the objects, they have to be homogeneous and distinct with other groups. All right. And with the example that we had, there is also a natural grouping within the data set with specific points. When it comes to similarity, it implies that usually when we look at clustering, implies a measure of similarity or dissimilarity. So between the data points, with the similarity, we are looking within the cluster, because in this particular case, the distance between the points is very small. Then with the dissimilarity, we are looking between clusters because the distance between the clusters is large. Okay? And then we've already talked about there are different ways on how you can measure the distance. For example, the Euclid distance, which I've talked about, but you can also use the Manhattan and then the cosine similarities. All those common measures can be used when you want to measure the common distance. And then also, in addition to the type of clustering methods I've talked about, there are some others, though we're not going to look at them in this particular period, but you can also do some further reading. I've talked about the hierarchical method. Here, like I mentioned, you create a tree like a structure. That is the dendrogram that I've just illustrated, whereby it keeps nesting different objects to come up with the different clusters. And then also, we talked about the partitioning, okay, whereby you divide your data set into a predetermined number of clusters, and this is the non-hierarchical method. For example, you can say my K, these are the K-mean clusters. You can say my K, or the number of clusters that I want, you can define them beforehand. Maybe you want 4 or you want 8. Remember, in case you've got, for example, a small data set, then it is likely that you're gonna, for example, say limit the number of clusters compared to when you've got a very big data set, among others. These other ones, for example, the density-based method and then the model-based methods, I would kindly ask you that you can read that on your own, but I'm only concentrating on the first two. Okay. On the different applications on clustering, you can use the market segmentation. Okay, it can also be used in imaging, document clustering. Actually, the point is it's about grouping. For example, within the market segmentation, maybe you might want to look at the different sales that are being made, and and then maybe you can also, apart from the sales, you can also top it with the age groups. Okay, then you can use those two variables or attributes to support you in the segmentation. Okay, briefly, let's look at the steps in cluster analysis, what we are going to do in R, or what we expect to see. And just to wrap up again, what I've just illustrated. So number one, you need to prepare your data. Okay. Number one is data preparation. Within data preparation, it's the same as like the things we looked at, data manipulation. You have to clean and then select the relevant features for clustering. Like we mentioned in the previous example, in the toy example, we said you can cluster by shape, by color, or by type. Okay, so which feature or which attribute are you going to use for clustering? All that is involved when you're preparing your data. And then remember, you're also supposed to normalize or standardize the data if necessary, because you find that sometimes when you collect data, there's a lot of noise. Some attributes or variables are bigger compared to the other. So we need to normalize or standardize such that we play from the same level, and then we'll be able to explain our results without having a situation whereby one variable contributes more compared to the other. So after that, for the case of the step number one, you've cleaned your data, you've gotten to see, okay, this is I'm going to use this specific attribute for clustering, and then where necessary, you've normalized. Number two, you need what algorithm are you going to choose, are you going to use? So depending on the nature of the data that you have and the problem at hand, you need to choose the appropriate clustering algorithm. And then, of course, are you going to use the hierarchical one or the non-hierarchical one? And then also, you need to determine the number of clusters if required by your algorithm. Are you going to use 2 clusters? Are you going to use 3, 8, etc.? That is when you're choosing your algorithm. Okay, then the other part is that you need to know how you're going to apply that. And then how are you going to assign the data points to the different clusters? You're going to see that in R. And then evaluating the clusters, we've already mentioned that for us to assess the quality of the clusters, getting to know that, well, this is the optimum that I'm going to use. I mentioned that we can also look at the within cluster sum of squares, because what we want to look at here is that we want to have the distance as small as possible within the cluster. And then we can also do that with the visualization, either with scatter plots, etc., depending on the appropriate method that you want. Okay, so among the common clustering approaches, this one I've already talked about it, the K-means clustering, all right, where we said it requires you to state the number of clusters that you want to have in advance. I've gone ahead to put some commands that you can use, for example, in case you want to run it in R. So here, in case we go to R, especially within the cluster self-read script that I sent, this is where you're going to find this particular commands, and then it will help you. For example, in this particular case, you put in the data set. Here we are considering the data set as the iris, the one that we are considering area. And then the K-means will give you the number of, it's supposed to get the results that you want to consider within the cluster. And then the center equal to 3, it implies that you're going to use 3 clusters. I've already talked about also the hierarchical clustering. This one, you see it in the self-read that I sent. These other ones are just also other common algorithms that you can think about. The visualization, you can use a scatter plot, you can use the dendrogram, you can use the heat maps. At least now we are very familiar with what these visualization approaches are all about, all what they do. Okay, so I'm going to I'm going to stop here, and then we'll move on to see how do we do everything in R, what I've just discussed. Okay. Kindly shared. I'm just going through the chat briefly to see if there are some things that you've asked that I can answer. Please, can you reshare today's document? When you go to the Google Drive, check in Dev 5 folder. Dev 5 folder has all these materials that I'm talking about. Okemo was giving an example that in taxonomy, it is used in the polygenetics. Wow, thank you. Thanks for that contribution. The dendrograms are already looking like our polygenetic trees. Yes, they can be applied in different fields, and also within your area of specialization, you can apply them there, and they'll support you to make the right decisions that you want. Okay, can you show us an example of data normalization? Okay, we are going to see that in R. How do we normalize data before we go ahead to do the clustering? All right, kindly explain the presence or absence between clustering the categorical variables. Okay, with clustering with the categorical variables, like I explained earlier, in that particular case, you find that it depends on the attribute. Like the one we saw that for the case of the shape, we had to check, in case we're using the shape, which variables belong to the same shape. So in the shapes, for example, we had like a triangle, a circle, and then a rectangle. So the clustering was just a natural process because the different observations were all the objects or the items that we are looking at were naturally grouping themselves. That toy P or Q was belonging to a triangle, or it was belonging to a circle or a square. So that is how that is how the categorical one is being done. But also, as we're going to see within R, we are going to see that, well, as we are trying to do the clustering, we are going to see that we can have the different plots and then cluster them by the different groups that you want to consider. Okay. Then the file of data not open. Ayan, how possible is networking with you as a junior in projects? I don't know. I'm not getting your question. Maybe you can rephrase it again. All right, we are going to stop here and then we move on to R. Okay, so now I assume that you've gotten the file, the folder within on your desktop or where you've been working from. I'm going to share my R script. Okay. Okay. I'm going to give you a break of 10. Okay, I'm going to give you a break of 10 minutes, such that you make sure you download the folder, Dev 5 folder, and then we start on R. See what we've been talking about, how is it applied in R.
I would say I can make some clarification.
Okay.
Some question is answered here.
Mm.
Once we start, say Philippines not that. We stress the analysis. Not a one to do just analysis.
Okay, it's now 10 past. Maybe you can.
So I'm taking all of them. My good friend. So you can say something.
Okay. Okay, welcome back. The 10 minutes have passed, so we are going to proceed. Dr. Thomas has more clarifications that he wants to make. Okay, Dr. Thomas.
Okay. Yes, good afternoon, everyone. Yes, there are a number of questions that I'm trying to answer from Q&A, and I thought it would be good to also say to the general group. Now, first thing is, how do we determine the number of clusters? I think Ellen has made some clarifications. But one thing we need to know about cluster analysis is that cluster analysis sometimes is highly subjective. And the assumption is that you know the underlying population that you're trying to cluster using information that is available. So sometimes you want to find out whether with the information that you have, are you able to see, I mean, you, for example, in genetics, or maybe let's say, for example, you get a lot of accession or plan accession from different places. And then you want to find out now, if I use phenotypic characteristic, do they cluster based on their origin, based on where they're coming from? So there's that knowledge, your own knowledge, that your theory that you come along with, that can help you to determine how many clusters you need. But the best thing probably with cluster analysis would also be to try, especially if you're doing hierarchical clustering, you try to say, in most cases, what you're saying is that you have a group. So you say, for example, if I divide this into 2 groups, what will happen? If I divide this into 3 groups, what will happen? So you need to be able to explore the content of the clusters that you made, and try to look at it in terms of what you're trying to study. When I did some work with cluster analysis, I had about 1,000 accession of, and this coconut were coming from different places. So some of them were associated with the Pacific, or with the Atlantic Oceans, and different countries. So the idea was, based on the molecular markers that we got, how do this accession cluster? So you do look at a situation where the first categorization would be, you have accession that are related to the Pacific Ocean versus those ones that are related to the Atlantic Ocean. And then when you go to the Pacific Ocean, you'll have some categorization. When you go to Atlantic Ocean, they'll have some categorization. So that also involves that you know exactly what is going on. You're not shooting entirely in the dark. So once you form those groups, you can construct, for example, what we call a confusion matrix, to actually see whether the clusters that you form make sense in relation to what you know on the ground. And there were also issue of can I use categorical, can I use binary data for cluster analysis? Yes. The whole idea here is that you should be able to construct distance matrix. So whether it is binary, there are lots of distant matrices that are based on presence or absence. There is like Jaccard and all that. So you need to be able to look at those ones there, especially those days when you were first getting markers and the markers were just presence or absence. So there was a lot of this genetic distance that are based on just on binary alone. You can also combine categorical or qualitative and quantitative. There are distant measures that can actually do that. At least I know there is the GOAS distance that can combine qualitative and quantitative information. So what we are trying to do here is we are trying to open up your eyes so that when you go out there to read or to do your things, you're more enlightened. You can venture a lot more than somebody who had not had that training. So we are not going to give you everything at a go. We are just trying to open up your eyes. All this information are available online. It's your own decision to decide whether you want to remain ignorant or you want to be enlightened. That's entirely up to you. Thank you, and back to Ellen.
Thank you so much, Thomas. I think that was a good recap, more clarifications on how we're supposed to do cluster analysis. I'm also seeing different comments that you're also practicing what we are teaching you in respective data sets and you're getting the right answers. That is good. So keep practicing. And now let's continue. Okay, so when you check in the Dev5 folder, if I closely check in the materials that I sent, there is you have an R script that is called clusteranalysis.R. So it is what we are going to use. Then the other R script, it is you that, like Thomas has said that, I mean, we give you some of the materials, but later you have to do the other parts on your own. You cannot like learn everything within 1 week and you feel like everything is exhausted. When it comes to especially data analysis, it's a learning process and you keep adding 1 or 2 things here and there, but it's about practice. So I'm hoping that you've been able to get the materials from the Google link, put everything in your working document, call it, maybe you have a folder on your desktop where you've put now the Dev5. So we are going to go through clusteranalysis.R scripts together. And then at the end of the day, we see how we've managed to apply the things that we've been talking about within cluster analysis. Okay, let me check in the chat if you've been able to get the materials. Are you ready to start on R? Type yes. If you're ready, then we get started. Okay, great. Somebody's saying no. I don't know why they are saying no. Yes, we are ready. Huh? You don't see anything. Somebody's saying no file. Let us. Okay. Someone is asking for the CSV file. Okay. Okay, let's get started. Number 1, we need to load our packages. So you can highlight everything and run, or you can just run each package depending on what you want. So when you look at line number 9, the data that we are going to run is from it is the utilities.csv data set. And this is the URL where the data is being stored in the GitHub. These are content. That's where we are. That is where the CSV file that you want to use is. You can also follow that URL, and then you'll be able to see the utilities.csv file. Okay? Make sure that when you run line 9, check in your environment and see if something has changed or nothing has changed. When you run line 9. Okay, can you type 1 in case you've managed to see my data? Okay, great. So with line 9, we are able to see that we've got the my data, which this is just an object name. You can change it to any name. And in case you want to view, you can click on the Excel icon, and you find that in this particular case, this is how our data looks like. We have the company name, that is the first column. It has many company names. We've got the fixed charge, we've got the ROR, we have the cost, we have the sales, and then we have the nuclear, and then the fuel cost. So these are just different variables within the utilities dataset.csv. And we have 22 entries. Okay? I'm hoping that at this particular moment, we can all be able to view our data, which I'm called the my data. You can also, sometimes you can, we can also export data from R and then to Excel. And then for you to do that, you can use the write.csv command, and then in bracket, you put the file name that you want, and then how you want it to be extracted in case you want to see the my data, as a CSV file. Then it will also be stored in the same what? In the same folder where you're working from. Okay, so I'm going to continue. Just the first things first when it comes to our programming. Remember, we said most of the time as you open your R script, you have to run the necessary packages, or in case you don't have the packages, you have to install them. After installing, you load them. All right. So we've seen line 17. In case you want to view the data set, we can also check the structure. Looking down here within the console, kindly do the same at your end. When you look at the console, they're telling us that it's a data frame with 22 observations of 9 variables. We also have the different variables. We have company and the fixed charge, etc. And we know that company, these are different types of company, so it is categorical. What we are going to do, we need to convert company to categorical such that R doesn't read it as a character. Okay, so, and we can see that under line 19. In case I run line 19, and then I run the structure of my data set again, I should be able now to see that company has got 22 levels. It's a factor with 22 levels. Okay. 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 Let me first check. Somebody wants to share. I first stop sharing. Whom have you promoted? Okay.
Okay, good afternoon.
Good afternoon.
Okay, so I was trying to load, but it's showing me some errors. I don't know. I started from here to run. It says error in library TDVAS. There is no package called TDVAS. I don't know.
Can you first click on the install there? There's install package up there. Up, you said the line before that. There is input. Can you put where this installed? You see that warning there? Follow that line of the warning, then there is install. Not there. Up.
Yes.
Click on, hey, you almost there. No, there's along that line, there is install, the word install.
I'm not seeing it unless I will.
No. You don't, you above line one, above your line one.
Mm-hmm.
There's something like a triangle there indicating some kind of a warning. Can you follow along that? And there is install along that line.
Okay.
You see package R, okay. Install?
Yes.
Okay. So can you clean up your console so that we see where the problem is? There's a brush down above the console. On the extreme. Yes, clean on that. Okay. To run what you want to run and we see.
It's not moving again. I don't know.
Okay, you try to run, okay, try to run line one up to 5 and we see. No, it's good to run one line at a time. Don't run all of them because you will not know where the problem is. Just make the cursor, put the cursor on the line.
It's not responding. Maybe I will.
Can you put the cursor on line 1?
It's not responding. I've tried to. Uh-oh. Let me try here.
Can you put the cursor on line 8? It's not responding completely.
Okay, let me
run that.
It's not responding completely. So let me reload.
Okay, then you close it off and start again.
Okay.
Are you going to share again? Can you share again?
Okay, let me share again. Okay, it's like you're having an issue. Let me just stop sharing so that I won't waste time. Let me see if I can sort out myself.
Okay, let somebody else show or Alpha. Alpha.
Sorry? To what? Unmute. Who?
Sorry,
Oh,
sorry.
Alpha, can you please unmute? Such that
Yes,
we
I've unmuted
okay.
now. Sorry. Yes, I am trying to haven't loaded the different the different packages, Tidyverse, Excel, Read Excel, Read R. I tried to run line 9 to get this data. We created this, and then I've tried to run line 9, but it's giving me an error in my console, as you see. It's saying,
Can you show your screen, please? You're showing
yes.
us something different.
Really?
Can you
Okay,
share
okay.
your screen, please?
Oh, okay. Share screen. Oh, I'm sorry.
Okay.
Yes, sorry.
Okay.
So,
Fine.
as I was saying, I haven't
Mhm.
I've loaded the various packages that we'll be using. I tried to run line 9, and for this my data object we created, but I'm seeing in my console, as you could see, it's saying error, cannot open the connection, and blah, blah, blah. So I don't know what's the problem. And the alternative also I tried, alternative one for line 14 for the right CSV. And I also got an error in eval expression object, my data not found.
Line 14 cannot, you can't run line 14 unless if line 9 is okay.
Oh, back to line 9. How I can solve this line 9?
Because with line 9, all you need is internet. That is all. And then
Yes, I had internet, as you could see. I run again. You see, cannot open the connection.
which could not resolve host name.
So I don't know the problem.
Sorry? That's it can't he can't read it. He's showing the red comments. Yeah. Hmm? 4.33. Okay, can you first clean your console?
Okay. Okay.
That particular Google and then try to see whether it can run stuff with that.
Okay. Option number 2. You can copy the URL into Google and see if you can see the data and you copy direct.
Option for line 14,
On
right?
line 9, we're on
Okay.
line 9, and then you copy from HTTPS, everything, and then you paste it in Google. And then you look for, yeah,
okay.
Copy and paste it. Go to Google.
Yeah. This is what I see. Company fixed charge. I see some data, but it's not in any format I can.
Yes, Thomas, are you saying the data that he's having? It's in text form.
Yes.
Huh? Mhm.
Yes, that's one, but can we send it in that?
Eh,
Yeah, but that is easy to send it as a, send it as a text. You know, you can correct this.
Mm.
This is serious. It's serious. But I mean, you can just save this way, put in the text, save the text, and then you can correct it. But if it's not take time, you continue.
Okay, Alpha, what we are going to do, you're going to save this data as a text, okay? And then after that, you're going to call into R within the text format, and then it will be, that's when you'll be able to see it within the environment, because this is the data that you're showing, it's the data that we are going to use with the company, and then the other different variables that we want to consider. That is a comma data set, comma, it's okay, download it as a text. Are you illustrating?
So you put a script, a text script. I know where they have a text script there.
Text. Let me find text.
Just paste
You just paste there, then you save.
Okay, let me copy it first. Just to save, I am to save as text format, right?
Yes.
Yes.
You copy it and
You
open it, just a text editor.
Open a text, just a text editor, a notepad.
Mm.
Is it open? Okay, paste it there.
Then I should
Just
save.
paste the. Okay. Save as.
So let me put it under the same, my data where I'm working right now, yeah?
Yes.
Yes.
Okay. Then what name I could give it possibly?
Just put that.
Just
DAT.
DAT. DAT dot text. It's okay.
You
can remove the dot text. It will save automatically as a dot text.
Okay.
Just remove the TST. Yes. And then, okay, save.
Save now.
Okay. So now you need to go to your studio.
Mm.
Hopefully it will work.
Hope so.
You can use the read lines.
The reading. Yes, I'm trying to clean my console, but I'm not seeing the broom.
No. Yeah, just okay. You're already in the. You need to set a directory where you put that particular one.
Okay.
Go to
Directory.
session.
Choose directory.
Choose a directory.
Yeah.
Is that where it's supposed to be?
Yes, I think I saved it there.
Okay. Then try to now put my data. Just type what I'm telling you.
My data.
I'm not seeing, you're not typing.
It's here.
No, type in up there.
Yes, I typed
Make
my
it line
data.
6.
Oh, in line 6.
Just put it down on a line 8 there, type there.
My data.
That's okay. You put the assign sign.
Okay. Okay. My data
read
is
dot
equal.
table. Read dot table.
Table. Take this, read dot table.
Dot table, not F table.
Yes, read dot table.
And then you put in bracket.
In quotes?
Yeah, in quotes.
Yeah, in quotes.
Okay.
Sorry.
That.txt.
And that dot t.
I only save it as dots. Dots.
Yes, but the txt will
Yes,
be there.
but the txt will be there.
.txt.
That's
Dot
txt. Okay. That's fine.
Go after. After that, put a comma. After the quote.
Okay, after the quote, comma.
And then SEP, SEP.
SEP. Separate equals.
And then
you put a comma and put a comma in, put a quote and a comma inside. The comma should be in a quote.
Comma should be in quote.
Yeah.
Okay.
Yeah.
In quote and a comma. It's okay.
Hey, but you're not. I'm not seeing.
Let me push this down. So, yes, you can see.
Okay. Okay. Try to run that and we see.
Yes, it's run. It's send me.
No, you did. We're still waiting. And
my data scores raw dots. So it's give me in the console. You can see in the console here. Let me try to clean this up.
okay, it has run. Now I want you to, can you type names, my data, and we see? Names with my data in bracket.
My data. I run.
Right, 10 or 9.
9. It's giving me
my data. First put my data in that bracket. I want to.
Yes, it's already there.
Oh, that's what it gives you. Okay. Now what you do, you put another comma after say, put another comma and say header equals true.
Again, please.
Go back to line 8.
Line 8.
After the SEP.
After the SEP.
You put another comma, then say header equals true.
After SEP, before the equal to?
After SEP, but it doesn't really matter.
SEP.
We want the first line to be read as the header where the names are.
Okay. SEP equals comma in quotes. After that, you mean?
Header equals T.
Head equals T. Head, H-E-A-D.
Put a comma first before you.
Yes, okay. Comma, head.
Header.
Equals T.
T, capital T.
Yep.
Run.
I run again. Okay.
Yes. Okay, good. I think you're ready to go, probably.
Thank you very much. Thank you. Wow. Okay, let me stop sharing. Thank you so much.
Sorry about that. You can hear me now? Am I loud? Okay, great. So I was also saying that we can have another option. You just copy the URL into Google, and then when you get to the point where you've got your data, you can right-click and then save it as a CSV. With that, you'll be able to come up with an Excel file which you can import. You know, the usual you've been doing it, like going into say directorate, choose directorate, and then guide R where you stored your data. That can also be another easy approach that you can use. But like we mentioned, if you get stuck, there is always a solution. And then from that, you're able to learn more. Okay, I'm going to share my script again. And then we proceed. Okay, so I believe now we are, when you come to, for example, when you come to line 21, like head, you can be able to see, you know, the first 6 rows of your data set. We've been talking about that from the beginning. We looked at how you can draw pair in case you want to have a scatter plot matrix. We mentioned that you can use pairs as the what? Pairs command from the GGARI package. In case you run that, when you check in your plot window, you'll see many plots. So I'm not going to go into that because we had a lot of time explaining what happens within the scatter plot matrix. So let's continue. From what we have, we can have, for example, a scatter plot where we are having fuel against the cells. With the fuel, I think that's when you check, you're going to use the fuel costs, okay? This is column 3, 1, 2, 3, where I'm highlighting in the console. And then also we have the what? The fuel costs. So in case I run line 27, if I run line 27, when you check in the console, sorry, in the plot window, we can see a scatter plot for the fuel cost and then the cells. Maybe as you can see, we can see some of the groups. We can be able to tell that this data point, we've got 3 sections. But what about in case we do the coloring such that it comes out more clear? Remember, these points, they stand for the companies, yeah? The companies that we are considering within our data set. So in case I include that text for companies, I want to put the labels, and then I want to consider my position as 4. In case I run that, from the plot window, you see that there's some overlap. In case you zoom out, I believe that you can zoom out from your end. In case I stop sharing that, and then briefly, if I share this, what we are having here is that we can see the different companies, and then we can also see some overlap. We see some of the companies at the extreme end of the cells, and then some of the companies are within the middle, and then we see some of the companies up here. Well, we are looking at considering the fuel cost and then the what, and then the sales cost. So I'm going to stop sharing this and then go back to R, then I'll explain more. Okay, in case I want to reduce the overlap, I can put the size of the text that I want, which is under the CEX, which is equal to 0.4. You can change it to any value that you want. For example, maybe you can give it 0.4, 0.5, etc. So in this particular case, this is just to help me to reduce the overlap that I'm seeing within the what? Within the plot. So in case I run line 31, let me first, I'm going to remove that. I'm going to run my line 27 again. Then I run line 31, okay? So I'm going to zoom and then share this. Okay, so all right, so what we are seeing in this particular case, at least we've reduced the overlap, but just by the size, so we can clearly see the different companies where when we are comparing them in terms of the fuel cost as well as the sales. Can I hear from you? What do you, basing on the plot that we are having, any conclusion or any explanation that you can give? Just type in the chat what we are having from our scatter plot. What would you say basing on what we are looking at right now? And then I'll supplement. Any comment on the results? Okay, so at alpha, okay, so Rita is saying 3 clusters. Nevada sells much by low cost. Somebody saying you're seeing 8 groups. No correlation, the names of the companies, no correlation, 3 clusters, no differences, high variation. We're seeing 3 groups. I'm just reading the comments that you're putting in the chat. No clarity, 3 clusters, okay. Can I get more inputs? Maybe more too. Somebody saying 4 clusters, no linear relationship, 4, then 3. Okay, dispersed, some similarity. Okay, so let's look at this. You find that we can look at this, basing on how our companies are split, and we are looking at cluster analysis. We have a group of companies whereby the sales are high, especially these companies, 1, 2, 3, 4. The sales are high and the fuel cost is low. I'm looking at the extreme right, where we've got the Navida, Paget, Texas, and the Antwerp. All right. So we have that particular group whereby it has high sales with low fuel cost. We have another group here in the middle whereby it has got medium sales as well as medium fuel cost. And then we have another group up here which has got low sales but with high fuel cost. So in other words, we can say that basing on what we are saying, we are having 3 clusters. Okay, I'm going to stop this and then I share my R script. Okay. All right. So I was just elaborated the where we wanted to see how the companies are distributed and how are they put into the different clusters, basing on the fuel cost as well as the sales. Those are the two attributes that we considered in this particular case. So that is just understanding, having a feel of the data that we are having. So the next thing that we are going to do, it's about normalization. Somebody was asking like, okay, in case I've got my particular data, how do I do normalization? Maybe just to take you back a little bit, remember where we had like head my data. I just want to bring out this again, and then, so this is what we are having. You find that basing on this data set that we are considering, yeah, there are some, for example, under the fuel cost, there are some that have got very small values, like this is 1.5, then we have the 0.7, yet within the same class, the same data set, we've got the cells, and we're seeing that the cells are within 1,000. Like we have 9212, then we have 11,127, etc. So the reason why we are normalizing, we want to ensure that we are working on the same plane. We standardize our what? We standardize our all the different variables that we are using to reduce noise. So what we are going to do, usually when you're normalizing, we're going to subtract the mean, and then we divide by the standard deviation. I'm not saying that this is the only method. There are some other methods, for example, that you can still use in case you want to do normalization of your data set. So with the first one, looking at line 42, I want to consider the whole data set, my data set, and then I remove company, okay? Then I remain with only the quantitative data. This is what line 42 does. It is removing all the first column, all the rows of the first column, and then all its rows. So in case I run that particular line, and then I run Z, what I will see is that now I'm seeing all my data points, but without now the what? The company, because these are the attributes that I want to normalize. So I want to get the mean, and then after getting them, after getting the mean, and then I also have to get the standard deviation. So I'm going to use the apply command. Now I'm dealing with the Z data set, the one without the company. And then I'm starting with I'm considering columns. So 2 means that we are doing with the different columns. And then I want to compute the what? The mean. I'm storing everything under my object name called mean. So in case I can run line 44, then I will see the different means within my environment. I can also do the standard deviation. What I'm changing here is just the SD, but I'm using the same command. So, and I store everything in my SDS, okay? That is for the standard deviation. If you remember, like we are doing sort of a transformation from, and then we want to have our data, which is within a standard normal distribution with mean 0 and then variancy of 1. So that's what we are trying to do. So, and I've already mentioned that we did the normalization because we want all our variables to be in the, to have the same level playing field, okay? So now I want to get NOR is going to be my object, which has got the normalized data set. And I put the scale function, my Z. This is remember the Z, it's a data set without the company. Then the center, these are the means, and then the scales are the what? The standard deviations. So I'm going to run this for me to come up with a normalized data set now. If I run that, I can also check and see how, after that I can run the NRO, and then when I check in my console, I'm able to come up with now what is a normalized data set. Okay, so having normalized, now we are going to move to go ahead and see how can we compute the distance. We are talking about the distance between the different clusters or within the different data points. And in this particular case, in case you're going to use the Euclid distance, we can use the command DST. And then inside, I put my normalized data set. I'm storing everything under the distance object. Okay, I'm going to first run the 3 lines, then I pause in case there is a question. So in case I run that, okay, I can check the distance. You find that what I'm having is that I'm seeing many points. And so I want to reduce such that I want to make it more compact by reducing the number of decimal points. Then I'll explain. So in case I put print in bracket, I want to print the distance, but this time around with 3 decimal points. So in case I run that, okay, this is what I'm getting. So if I run up to 3 decimal points, this is what I'm getting. Remember, we are printing the distance in between the different clusters. So here, what we are having, for example, let's take an example about distance between compound 7 and then 11. This is where they intersect. I'm considering 11 here, and then 9. You find that this 6 is a very big is a very big distance. So it implies that we cannot cluster compound 7 and then 11. But surprisingly, in case you move down, we are having 1.66. So it implies that we can group compound 7 with compound 12 because the distance in between is very small. It implies that these companies have got similar attributes of interest that we are looking at. So you can look through again, and then we can also take for another example, like 1.49, considering compound 4 and then compound 10. The distance in between is very small, so we can group them under one cluster. Okay, where we see that the distance is very big, then it implies that we cannot group those 2 companies within the same cluster. You can also check through, and then we can still see, for example, with compound 4 and compound 20, the distance that is very small, so we can also have 4 and 20 within the same cluster. Okay, let me first check in the chat and see if we've gotten how to read the matrix distance. Is this part okay? Yeah, I haven't also understood. Would you mind to send me the Google Drive? Okay. Okay, I can repeat it again. No. Okay. Let's go back to somebody saying that he has not got the normalization part of it. I'm going to go back on line 39. Okay. I remember, I think yesterday, when we were talking about normalization or having our data points within the same unit, where we are using the scale command. If you remember in yesterday's presentation, where we are using the scale such that we have all our data points within the same within the same scale. So here I'm talking about normalization. It is also the same thing. Sometimes we do data transformation. When you're when you're doing data transformation, it implies that you're transforming your data to a standard normal distribution. Within a standard normal distribution, you're taking it in the sense that it will have the standard normal distribution has a mean of 0 and standard deviation of 1. So what we want to do with our data set, that is what we want to do data transformation, because from what we have, our data has got different means and then different standard deviations. And I showed you, for example, that looking at these 6, the first 6 rows here, let's go into the fuel cost. I was saying that you might find that the cost of fuel, for example, here it's 1.55. The quantities, the different prices are really very small. But when we come to the cells, you find there is another variable which has a big value like 7077. And then when you move on, we also have another company which has cells of 3,300 and then 11,127. So in this particular case, the point is, why are we going to normalization? Here, the noise is very big, all right? So when we normalize, we are trying to reduce the noise within within our data set. Okay, we need to work from the same playing field, because we see that when you check for the case of the cells, the values are very big compared to other values, while even when you check for the case of the fuel cost, the values are too small. And so it is the reason as to why we need to go ahead and normalize our data sets. And for us to do that, this is, we run line 49, okay? I first removed the variable, which was company, that is line 42. I viewed my data set. Now I viewed Z without the company variable. So I wanted to get the means and the mean, which I stored everything into for the different columns. So I ran line 44, as well as the standard deviation. And after that, for me to come up with a normalized data set, I ran line 49, which has the inputs of what I have above. So in case I run line 50, I'm able to come up with a normalized data set. Okay, and this is what it is showing me with the fixed charge, with the cost. At least in this particular case, we see that there is no big difference between the attributes or the variables that we are having. And they've got, in case if we are doing the normalization, we assume here that now the variance is 1 and then the mean is 0. Okay, let me pause and check in the chat. Are we on the same page there? We removed company because we wanted to, companies categorical. It has got different companies, 1 up to 1 up to 22. Okay, we wanted to have the variables with measurements, or we wanted to get the quantitative data to have this to be within the same scale. Since the other variables, since company is categorical, it's a reason as to why we first removed it, and then we wanted to normalize the rest of the variables that are quantitatively measured. Okay. Okay. Let's continue. What does mean? SDS is standard deviation. Like we defined it earlier here, that we want to get the standard deviation for our attributes, and then get the means for our attributes. That's why we're able to do the normalization. Okay, somebody's saying that, what if the main and the max limit? I mentioned that there are different options that you can use. And as you move on, as you become, as you get familiarized with R, you might find that, well, using this particular approach, maybe it's lengthy and it is taking a lot of time. And then there is also another approach that you can use. We looked at the global min max, which you're suggesting. It can also still give us similar results. So it doesn't matter whatever approach that you take, provided the main aim is for you to normalize your data set. So I agree with you. Okay. So okay, somebody is asking why negative and positives. You find that remember we said our mean is when you normalize, the mean is 0 and the variance is 1. So when you add everything up, it's supposed to give you, when you add all the positives and the negatives under each respective column, you're supposed to come up with what? You're supposed to come up with 0. So that's why we are having it like that. So what exactly does? Okay. So, and now having normalized the data, now we are moving on to see how we, remember we said, how do we calculate the distance between two what? Between 2 points. And this particular case, we are going to consider the distance between our objects, which are the companies. So here, I'll run line, I'm going to use the dist command, okay? And then I want to get the distance of the NOR. That is my normalized data set. And I'm storing everything under an object called distance. After that, I want to print everything. I want to print the distance to 3 decimal places to make it more compact and I'm able to see it clearly. So I run line 54. I move on to line 55. And then you can see that when you, from line 55, we are having 1, 2, 3, 4, 5, 6. We are having up to 6 decimal points. So I move to line 56 such that I reduce the number of digits or the number of decimal points. And I'm telling R, give it to me up to 3 decimal points. So in case I run line 56, so this is what I'm able to get, okay? We have on the right-hand side, if you check here, I'm going to highlight this. We are having the number of observations. These were the companies from 1 up to 21, okay? And then also, when you look on this other side, we also have this particular line that runs from 1, 2, 3 up to 21. Up to 22. Okay, so I was just giving an example because remember what we said, that when you're looking at when you want to know the distance between between the classes, those that have got small distances, they are grouped within, they are put within one group, and then that's how we are able to do the grouping, that, okay, this particular company and this one, we can group them, we can put them under one group because they've got small distances in between them, implying that they share similar attributes of interest that we are looking at. And I gave an example that, okay, let's take like, in case you consider this particular distance, and this one is an intersection of through company 7 and then 11. 6 is very big. Some said that in this case, you cannot group companies 7 and 11 together. We want to group companies where the distance are very small. In case we take an example, for example, here of 1.6, we can see that 7 and then 12, we can group them under one cluster because the distance in between these companies is very small. You can also check for this particular distance, which is the one of 1.4, and this one is the distance between 10 and 13. So we can group company 10 and 13 into one cluster. Where we've got big distances, it implies that those particular companies cannot be grouped within one cluster. And that is the communication we are trying to get from line 54 up to line 56. What we are noticing here that the print gives us the distance among observations. These observations were within our records were the different companies that we got. So we are asking ourselves, how close or far is one observation is from the other? And I picked the one of like 6 that go through company 7 and then the one of 11. So because the distance is very big, then and we cannot put them into the same cluster, then we can say that they are dissimilar. Where we see that the distance is close, much closer, so in that case, it implies that there are a lot of similarities between those two companies, especially as per our attributes of interest. So there are a lot of similarities, whereas where we've got a bigger distance, it is dissimilar, implying that these companies are different. We cannot put them under one cluster. Okay, let me check in the chat. Is that okay? Okay. Sorry?
But what constitutes the bigness in our lives?
Show the points. Like saying that above 1. Okay. So in this particular case, okay, let me illustrate again. So what we are going to look at here, like when it is above something above 1, we'll say that, remember we said that with the intra-cluster. Sorry?
Yes, I mean, I want to say something for future. I think I'm going.
Is she sharing? You promoted her? Halima, can you share? For the intro, so. Yes, Livia is saying that small is best because we are grouping with similar characteristics. Yes, because remember we said that within clustering, if objects have got similar characteristics, then it implies that they are very close to each other. So the distance in between them is going to be small. So in this case, what I'm using, I'm considering the one that is within the range of 1. Above 1, then that is a what? A big distance. So like with when we looked at the example of the toy, where we had that within a cluster, we had were all triangles. Esther, can you share your screen?
Yes, please.
Okay.
So please, I ran the line 9. And this is what I got.
Okay. When you look in the environment, what do you see?
I'm seeing 22 observations of 9 variables. So I have that one.
Okay.
So where I'm
Run line
confused, I want to.
17.
Okay.
What is the problem?
I want to view the data.
You want to view the data. Okay, run line 17.
Okay. Okay.
Okay, so what you're seeing
So
is
please, so yes, I've seen the data, but will it not show in the console?
that come again. You want to see the data in the
data
console?
not show in or I don't know if you get me. I'm asking that, would I be able to see this data in the console?
Yes, you can. Okay, let's go back. Click on the cluster analysis.R. Click on it. Okay, so enter after that. Just create space.
I should create what, please?
Enter there and create space.
Okay.
Just type my data. No, don't put, there's no space. You're calling your set my data. Don't put space.
Okay.
Okay, then run that line.
No. It's not going to run. Okay.
Please, am I on the right track, please?
I think so, unless if you have a question.
Okay, I think I'm okay. I'm okay. At least I can follow from here. Thank you very much.
Okay. Thank you too for sharing. Anybody else? Anybody else who wants to share? Samuel, you want to share? Samuel wants to share. Chuku. No. Sorry?
You have enough time? Next one, next one, finish.
Okay. After this one. Okay. Samuel Chuku, can you share? Samuel, are we on the same page? Okay. Please share.
Okay. Looking for my own.
Yeah. Yeah.
You
I'm trying
look, there is a green button which has share screen. You
Yes,
have
I
to click. Hmm?
do that. I'm looking for my
You're looking for?
app. I already opened, but can you see my screen now? Not yet.
I only see your face. I don't see the R script.
Oh. Okay.
Okay, great.
Can you see the R script now?
No,
Not really.
I'm seeing I think from internet, because what it has top 10 machine learning methods with R. It's not your R script. Share the script where you've been working from.
That's what I'm trying to share.
No, Samuel, first stop the screen. You selected the browser, GitHub. Stop sharing and then you select the other screen. Because I know that you saw multiple screens on your window. So that's why.
Okay.
First stop sharing. Or I can stop sharing for you.
Maybe you can start from there.
Okay, let me stop it and then now I've stopped. So please click share. Then select the window which has R. You again first go ahead and close that window which has the browser. Let me stop again for you. But when you are selecting, make sure you select the R. the R, because now you are sharing the browser. Are you able to? Okay, I close that window where you are searching for the top machine learning methods, and then only leave the arrow window which is on your screen. You might be having multiple things which are open. Have you closed it?
I'm seeing Arrow Studio. Is it that one?
Yeah, this is okay now. Yeah, go ahead. Yeah.
Okay, so when I try to run line 8, line 9, I don't get anything. I think the data is not, I try to set working directory, nothing is coming up. I think it's from the CSV file or what. So can you guide?
But still, I think we looked at that already. Okay, so Samuel, are you seeing in the console on the top right, there is a button that it is red. Are you seeing that red button?
Yeah.
Yes. Don't stop it. It is showing you that it's still running, so you have to wait until when it is complete, and then you'll see the data. But I think you can borrow from I think there's from the previous person who shared. You can just copy the URL into Google, and then when the data set opens, save it as a CSV, and then you can just import it directly in the normal way. That can also help you to solve that problem. Copy that line. Yes.
Okay. Is that okay?
Mm-hmm. Paste it in your browser.
Okay.
Are you seeing anything?
Yeah, something. Yeah. It's in text form, so I should save it.
Yes, then right click and save as a CSV, such that you have it in form of an Excel, and you can import it normally. For example, using you can choose the directorate, and then you can import it into R.
Okay.
Are you seeing the different options that save as?
Yeah, I save as under save as. I have a under
Okay.
file name. I think it's under file name.
Okay, sorry?
Save as type is only Microsoft Excel, comma, yeah, CSV, yeah.
Okay, what we can do, stop sharing, then I demonstrate it for you very fast, and then we continue, given that.
Okay.
Is it okay?
Yes, yes.
All right. So just do what I do. I'm going to just share my browser. Did you receive something like this when you pasted you into the URL?
Yes, yes.
Okay, so what you do, you right click anywhere within, and then click Save As. Are you there?
Yeah.
So when you click Save As, it will give you an option of saving as a CSV. And then for me, by default, it is giving me utilities as the file name. And then you click Save. When you click Save, you're going to come up with an Excel, a CSV file.
Okay.
Are you getting that?
Yes, yes.
Okay, so it implies that. So now I'm sharing your CSV file should look like this. And then you can import it the normal way. Have you gotten the CSV?
Okay, let me confirm it. Yeah, I'm seeing utilities. It's trying to open. Yes, exactly. Company fixed up to full cost. Yes, it's there. So how do I import it?
You import using the methods that we learned earlier, how you can import data. Because the challenge was on having data.
Okay, that is under setting of working directory.
Yes, you got the working directory, then create directory from your folder, and then you'll have it into R.
Yeah, I think I'm okay now.
Okay.
Thank you so much.
All right, let's continue. Going back to my R script. I'm sorry, I'm going to be a little fast now, such that we complete, and then other things you learn on your own as you practice. Okay, so we are going to move on to we want to see how we can use the hierarchical clustering using the dendrogram, okay, which is also agglomerative clustering. So to do that, we are going to do everything by default. Remember, I talked about the complete linkage and the single linkage. So by default, R does the complete, okay? So we are going to store everything. So now we are going to store our distances. Remember the distances we talked about between the companies? We are going to use function h-classed, whereby h is hierarchical and then classed is the cluster. And I'm putting now my distances, okay? And I'm storing everything under my data.h-classed. So in case I run this part, in case I run line 70, okay? If I want to see how it looks like, I can run my object. And now I want to plot the dendrogram. So I get plots and then I put in the my object name that I got earlier. So I can run that. If you check in your plot window, it has changed. If I can zoom out, okay. So if I zoom out, this is what I'm having. And even you can see that the method that has been used to cluster, it is the complete one. Remember the complete linkage and then the single, but in this particular case, by default, R does the complete. So what we are seeing here, remember what we had is that at the beginning, for example, in this particular case, every company is a cluster. By looking at distance, then they go grouping them in, checking the distance that is in between, then they group those particular companies. We can still go back and check, for example, like here, they grouped company 10 and 13 together. When you look at it, actually, in this particular case, even when you look at company 12 and company 21, it was grouped into one cluster. Where you see, these are our nodes, and then where you see that this one was a grouping that, if you can look at this 12 and 21, initially, everything was a cluster. But given that the distance is small in between them, then we can collapse it into one cluster. So I want us to go back again on the distance and check where we want to check 12 and 21. We want to check then 10 and what? 10 and 13 and see, are these distances in between them really small? We can also check between 14 and 19 here, and then we have 1 and 18, just those few. And then I'll come back here. Okay. If I go back and I share my R script. So let's check again in our distances, all right? This is what we had. Let's check. They have grouped 10 and 13 together. So if I check 10 and I come and I check for 13, are you seeing that the distance in between was very small? So that's why when we check in our plot that they are grouped under one cluster. So we have 10 and we are having 10 and 13 that was put together. We also saw 12 and 21. So in case we check for 12 and then we go for 21, we still see that the distance between those two companies, it was 1.38. It's the reason as why also those two companies formed a cluster. I'm trying only the last one, which was 1 and 18. If you check 1 and move down to 18, we still see that those two companies were close to each other. Hence, they were grouped under one cluster. Okay. I think that makes a little bit of sense from those that were asking, why are we, for example, maybe saying that they belong under, maybe how are we saying that with this particular distance, then we are grouping them together. Okay. Also, you can put the company labels in case you're interested. That is line 72. From line 72, in case you run it, you find that you're now, instead of having numbers, the numbers are being replaced by what? By companies. Let me stop sharing this, and then I can, okay. Just to show you the effect, and then we continue. Yes, now, instead of the numbers, so now with what we are seeing are the what? Are the companies. Basing on the distance, for example, we've just seen that Manson is close to the northern. So all what we are seeing, so it implies that now this one will collapse into, when you're looking at New England and United States, instead of now 2 clusters, it will collapse into 1 cluster. And then as we move ahead, you find that now what we've collapsed into 1 cluster then becomes closer to Pacific. So we keep collapsing, and then we move until, for example, when we get to height 7, whereby everything has been grouped under 1 complete cluster. Like I was showing you, because this approach is subjective. For example, in case you put a line and it cuts across here, and then you can be able to count the clusters that you have. In that particular case, you can count clusters 1 and 2. Okay, I'm going to stop sharing that and then go back to my script. Okay, I'm going to stop. I'm going to do this one and then I stop. Okay, because of time, I'm going to run only this last one, and then the rest we can keep talking, and then because you also need to give out the evaluation form. So line 73, in case I want everything to align on the same level, on the same line, I include an argument called hang equal to -1. When I run that, this is what happens, what I'm going to show you. So in case I stop sharing, and then yes, so we are getting the same plot, but only that this time around, everything is on the what? Is on the same line, but we are using the same method. What we are building everything from the different distances that we calculated to come up with the dendrogram plots. Okay. So looking at the R script, we've not completed everything, but since we said that it's a learning procedure, we can keep learning. The other bit that we missed to here, when you go, it was going to give you cluster information on how the clustering was done and then the grouping. So I'll just leave this for you to do the practice, but in case like you get any challenge, feel free to contact us, and then we'll guide you. And then also the other thing, as you're running through this R script, I've put different notes that you can still follow. Whether you see the comments, there are more explanations on the different plots that you're going to come up with. And then at the end of the day, coming up with the different information that we discussed during the theory part. So over to you, Professor Susan.
Thank you very much, Dr. Namaweje Helen. We have a short evaluation that we would like you to fill in. We are going to post it in the chat and in the Q&A. It is in the Google Docs. So you just fill in and send to the highlighted email so that we can get your feedback. The feedback is going to help us improve the way we deliver to you. So in 1 minute, 2 minutes, let me have my colleagues send the evaluation. Is that the evaluation being sent? Okay, great. So I don't need to go and open. Did I go out?
You put on your camera. No, you are in.
Okay. Okay. So please take off some time and fill the evaluation. It is short. But we are really so grateful for the time you've given us to share our knowledge with you. It's just the beginning. We hope to have more of these. When our organizers call us, we will always be ready to come and share with you. So I'll give you another 2 minutes to fill in that questionnaire. Then I'll hand over to Dr. Runyararo to close. In the meantime, Dr. Thomas can say something since he has been quiet.
Hello, everyone. Yeah, thank you so much for this week. We are happy that you are obediently and willingly sitting here for 5 good days listening to us. We don't take that for granted. We also like to thank Reforum for giving us this opportunity. But we're also saying, in case you want us to do a training for you, we are always available. So you can talk to your bosses, look within your projects if you want to think. Even physically, we can come to your country or whatever. So I want to still re-emphasize that what we have done here is to open your eyes so that you can go and read more, look for more, and also utilize this method. ARA is something that you need to use from time to time for it to stick in your head. If you don't use it, it will disappear. Yeah, but the good thing is that you have the internet always at hand. Even me, I really check a lot. Sometimes I need to check if I've forgotten something. I checked. I started using ARA, I think, in 2005. So it has been a long time. So, but I'm always learning. Something new is always coming up. So we are very grateful for this opportunity, and we hope we have been of great help to you. So thank you so much.
Thank you, participants. We also thank Reforum for organizing this training. I now hand over to Dr. Runyararo or any Reforum staff who is online.
Thank you so much for having this training for 5 good days, for 3 hours every day. We are so grateful to Professor Susan Tumwewaze, Dr. Helen Namaweje, and Dr. Thomas Odom for creating time to come and share the knowledge with Africa. We are so grateful to them. I am seeing colleagues who are saying certificates. Unfortunately, in this training, we do not provide certificates. This is just to enhance your knowledge base in statistical analysis. So this is to your own benefit, not to just have a paper. So unfortunately, we shall not be having papers. I see others who are constantly asking for contacts for our facilitators. Please type their names on LinkedIn. Link up with them on LinkedIn. They'll be happy to help you. wherever you would need their help. And also, I would encourage all of us to be in our WhatsApp groups. We also get help from colleagues when we are facing challenges. So let me take this opportunity to thank all of you for attending this training. Let's meet again when we have other opportunities for you. Thank you so much, everyone. Have a good afternoon. Bye.